All right, so to wrap up this discussion of structure and bonding and properties, where I'm going to kind of delineate the physical and chemical properties that we've talked about previously and place them further into two other categories that where these properties either depend on how much of the matter is present or they don't depend on that. And so if particular property, depends on how much matter is present, that's an extensive property. So an extensive property depends on the amount of matter present. And so an intensive property would be the opposite. The intensive property does not depend on the amount of matter. So some examples of an extensive property are things like mass. Obviously, if something has more matter, it's going to have more mass. So if you weigh a tablespoon of sucrose, it's going to have a different mass than if you weigh a cup of sucrose. Another thing that, for example, is volume. Volume is matter dependent. You could have a milliliter of water, or you could have a whole liter of water. And so the volume of water or the volume that that water occupies depends on how much water there is. In regards to, like, for example, chemical reactions, energy that's released or even absorbed depends on how much matter is present. Think of, if you have a very, very, very small amount of an explosive, like a very small firecracker, it's going to release a lot less energy than, say, um, if it were a very large, like an M80 or something like that. And so the amount of energy that released is dependent on how much material is there. It's the same thing as if you were to have a piece of paper and set it on fire. That amount of energy that that piece of paper provides is a lot less than if you were to, say, light a whole ream of paper on fire. There's a lot more energy that's released. Some examples of intensive properties are like, for example, temperature. Let's say you put an ice cube in the freezer, and then you cut that ice cube in half. If you look at each two halves, they have a different amount of matter than they did before, but they're still at 0 degrees Celsius, still at the freezing point. Or density. Density, we've talked about in lab. We'll highlight a little bit later, but density is the ratio of mass to volume. That doesn't change whether you have a little bit of matter or you have a lot. The density of water, of liquid water, is always going to be 1 gram per milliliter at a certain temperature. It doesn't matter if you have 1 milliliter of that water or if you have 500 milliliters of water. Water is always going to have that same density. Or things like boiling point, melting point, color, hardness. Those properties don't depend on how much matter is present. And it's possible for matter to have both types of properties simultaneously. Like, for example, let's compare. Well, let me back up a little bit. When I usually make tacos, I like to fry the taco shells. And so I'll fry them up in some vegetable oil. And one of the frustrating things about dealing with that is sometimes the oil splatters. Um, Now, the oil is all at the same temperature. So if a little bit of oil splatters, that drop that splatters out has the same temperature as the rest of the oil if a lot were to splatter out. Um, but if a drop of oil splatters out and gets on my skin, yeah, it's a nuisance. It burns a little bit. Maybe it leaves a little bit of a mark temporarily. But if a lot of that oil were to spill out, and like spill all over my hand or something like that, like if it were to come out of the pan, then there would be a lot more energy released and that would create a lot more trauma to my skin than if a small amount of oil were to make a contact with it. Regardless that both types of or both amounts of oil would be at the exact same temperature. So I just want to kind of emphasize that it's that these properties aren't necessarily exclusive to each other, and matter is going to have both types of properties simultaneously. So that's where we'll wrap up with this chapter, and you will see the next chapter up fairly soon.